right, good afternoon. So I'm Mark Shaw. I manage hardware development at Microsoft. We're building the cloud. And when we talk to many customers and that sort of thing, we get questions about why did you choose what you chose? You know, why is Project Olympus the way it is? Why, why this, why that, why the other? And so I thought it'd be really informative to give you guys a, walk through the questions that I hear the most. So the first question, if you saw the keynote this morning, you saw that the Project Cerberus on stage. That's our new security emphasis. We have a new joint project inside of OCP on it. And one of the big questions is, why do you want to take this out public? Isn't security something that should be really, really quiet? Why open source this? And so one of the big deals is that this really goes across the entire ecosystem, the entire industry. And only way to do that is to work with everybody. And you actually end up with better security solutions when you have multiple people trying to break it, trying to come up with, what are the best ways to defend it and make it better and stronger. And so we need security across everything, even your hard drives, your flash drives, anything that has firmware has to be secure. And so that's why we're working through OCP to bring this public. Okay, this question, I even got this question in the lunch line today. So why 19-inch rack? They say, why not the why not the OCP rack? Well, you know what? Open rack is one solution, but the 19-inch rack is very, very flexible. And so the Project Olympus, what we've contributed over 20 specs, collateral designs, they all work in the 19-inch rack. But what happens really is that we need to move very fast, and there's lots of equipment out there that still works in 19-inch racks. We can just drop that in and go. When we were looking at racks for this new architecture, we were trying to decide what should we do. Well, we went out and we found, there's a 48U, there's a 50U, there's a 42, there's a 52, a 54, just about any size rack we want. So we said, okay, we can standardize on our sizes, 48 and 42, but for almost little, for very little effort, we get an Olympus, we get an OCP rack. And if we went to other types of racks, we'd have to do a lot of engineering and development. So the other thing that's really important to us is that in our infrastructure, we mix storage and servers together. Project Olympus is very flexible. It's a modular architecture. You can put anything you want into this rack. And the 19-inch rack, it's 1,200 millimeters deep. It actually provides a tremendous amount of volume. The sidewalls are very strong. Our designs are actually, what we deliver to the data center is pretty much constrained by weight, so 3,300 pounds. And if you look at the structure inside of these racks, it requires a very, very strong sidewalls. And that comes basically as an off-the-shelf offering with the 19-inch rack. All right. We have a very unusual power supply. So we deliver AC power. We distribute AC power throughout the rack. And inside of each server, there's a single power supply, but it's got 3 power supplies in one. It's a 3-in-1. It's a 3-phase power supply. And why do we do it? So it ends up as a better, lower cost solution for us than if we did, for instance, N plus N power. So if you do N plus N power, that means you have to have twice as much power. What we have is N plus 1. We only have 50% more power, so we're paying for less power. But probably more importantly is across 3 phases, each of the phases are balanced. They're all accepting the same amount of power. At the data center level, when you fill up an entire data center with equipment, what you need is each phase to be accepting the same amount of power. And if you can't do that, you have to reduce the amount of servers in your data center. And reducing the servers in the data center costs money. it means that you're wasting money on the data center. And so three-phase keeps, keeps our costs best. All right, why do we have out-of-band management? So many people use what we call sideband management. They run the management through the NIC and up into the switch. Well, what we've created is a management infrastructure that talks to every single device in the rack. And Project Olympus is a modular design. So you can see it at our booth. It's got JBODs, JBOFs, everything. Every device talks to the management. Every device has a BMC. Every device provides telemetry on power, on cooling, on faults, on maintenance, that sort of thing. We can manage firmware updates. There's a lot that you can do through management when you use out-of-band management. And so, it's just so easy to implement, and it provides all the information we need. And if you for instance, we're building an expansion chassis, and then you have to figure out, okay, how do I actually have the server talk to the expansion chassis? How do I make sure that the power actually turns off? I've seen a lot of designs, well, you just don't turn the power off. And it's like, well, that's crazy. You want to be able to turn the power on and off, right? So this gives us that control. Another question is, hey, you got 40mm fans in the server. How could they possibly be efficient, right? Because everybody's been in a room where someone cranks on a server with a little 40mm fans, and they light up and they start screaming, making an incredible amount of noise, which can't be efficient. Well, what we've got is there's two parts of this. The first is that we've got a very efficient thermal solution. So the first thing we did was we added this remote heat sink. It's a very large heat sink. It's got heat pipes going to the back. It's filled with fins. And what that allows us to do is significantly reduce the total amount of air that's required to move through that server to keep it cool. So if you normally needed that much air to keep the server cool, you now need this much airflow to keep that server cool. And when you run those fans at low RPMs, they don't consume very much electricity at all. So our overall energy consumption for cooling is very, very low. The second part of this is that, like on our previous design, we had a shared fan wall. We had a fan wall that was about this big. It had 6 fans. But you had to set the fans to keep the hottest server cool, which means, statistically, you look at some servers are warm, some servers are cool. You keep that one server cool, then the other ones are really cool, but you're overcooling those. And so when you have individual modules, you can mix and match anything you want in there. Each module consumes only the amount of air that you need. And overall, when you look at your applications, you end up with less airflow being run through. And that actually saves money at the data center. The data center uses less energy to run the air handlers. Another question I get, especially out at the booth, they'll say, hey, there's a bunch of empty space there. You should put something there. Why did you do that? That's crazy. You're wasting space. Well, really, that space is reserved for storage. So you can see in the 1U server, yeah, that space is empty, but we have the 2U server. It's got 12 hard drives. We have a JBOD with 88 hard drives. We need to mix and match all this different equipment into the same rack. And to make it all standardized, modular, easy plug-in, we use the same depth, and that requires some extra space. Another question is, why don't, I've seen these JBODs with servers built into them. Why don't you build your server into the JBOD? Well, the biggest thing is cooling. So the hard drives need to stay cool, and they need to get the best performance. So if you're putting a server and a hard drives combined, you're competing for airflow resources. And so if the server needs more air, you're going to blow more air through the hard drives. Guess what? You're going to add more vibration to the chassis, and you're going to create what we call acoustic vibration. Basically the air will whistle going through there. It'll reduce the IOPS and the performance of your hard drives. All right, another one is the HGX1 GPU accelerator is huge, it's big, it's expensive, you know, it's 8 GPUs. Don't you have anything smaller? Well, we are partnering with ZT Systems on a smaller system. It's a 3U system. It takes an Olympus motherboard as the base, and it adds 3 risers. And on each of those 3 risers, you can put expansion cards. So on each of the expansion cards, you could put either like 2 GPUs, or if you have smaller cards, you could put 4 of those cards. So that gets you 6 GPUs in 3U if you want, or you could put 12 smaller cards, and so that's providing a tremendous amount of flexibility. And the best part is it works in the infrastructure, and it's based off of the building blocks, all of the Olympus building blocks, you know, the motherboards, the power supplies. It's all in there, and it all works. And we'll be able to take that chassis and put, you know, when the next motherboard comes, just plug that motherboard in, and boom, we have a new chassis, and it just works. And one of the best questions about this that I receive is, well, why even open source your hardware? You know, isn't hardware, you know, special? Isn't it, you know, isn't it your intellectual property? You know, isn't that what really provides the value for your systems, for your service? And it's like, actually, the hardware really isn't that special anymore. You know, you know, everybody's got a reference board. You can go to any vendor, you can get, you know, any CPU you want put on a board. What it does is it allows us to put our software on it. So all the magic is in the software, right? We simplify the hardware as we can, but through the community like this, look at all the people around here, look at all the vendors. What we get is an ecosystem filled with vendors. We're getting all of these components. You know, we have Intel, AMD, Qualcomm, Cavium motherboards, 4 different vendor motherboards, all work into the system. We have JBODs, we have GPU accelerators. You know, now we'll have 2 versions of GPU accelerators. You know, we have people in the ecosystem, partners working with us, delivering all this equipment. There's lots of equipment that you'll find out on the floor that's actually Olympus compatible, and so that's been the best part of open sourcing the hardware. And I realized I ran pretty quick, so I still have a minute left. And so I had a question today at lunch, is like, hey Microsoft, how can I buy your hardware? Well, you can't buy it from us. So Microsoft doesn't sell hardware. We sell a service. We'd love for you to come try out Azure, but you can purchase this, the Olympus hardware. ZT Systems and WeWin are both selling different parts and components to Olympus. Intel motherboard, or Intel servers, AMD servers. You know, I think Quanta has some components out there that are for sale as well. So, as for you to you know, of course, check out Azure, but try out, or you know, check out the other booths out there. Check out what's available for Project Olympus. So if you have more questions, we do have more presentations. There's workshops tomorrow. We have 2 hours of workshops tomorrow morning, 9 o'clock, across the hall here. And you know, feel free to catch us at the booth or catch me afterwards for any of your questions. Thank you.